All right, so let's talk about test 3 review. So after completing the problems on the test review, reviewing in Alex, and looking at the practice sheet in Blackboard, you should be pretty comfortable for the test. So for question 1, we're asked to rewrite without exponents. So all these problems without exponents. So remember that whenever we have negative exponents, we have to make them positive. And to make them positive, we have to cross the fractional bar. So this will turn into negative 1 over 9 squared, which then squaring the negative will go away, and we'll get 1 over 81. Okay, the next question we have is 3 to the negative 3. Same idea, 1/3 to the positive 3. We square both, or cube both the top and the bottom, so we get 1 over 27. Okay, for part C here, we have a similar one. This whole thing should be to the negative 4th. So we need to make this positive. Whenever we have a fraction and then we're going and we have a negative with that, we swap it. So we should have 2 over 1 to the 4th power here, which turns into 2 to the 4th, which turns into 16. Okay, whenever we have fractions as exponents, remember that indicates radicals. So 1/2 is the square root, so this will be 2. We have the negative 1/3 in the exponent, so we're going to have to first deal with the negative, turn it positive. Now we need to take the cube root of 1/8, and we know that's going to be 1/2. And the last problem we have here is 16 to square root of 16, which is 4. All right, let's rewrite the following for the indicated variable. So we're solving for t. So we have pt plus y equals 3x plus 1. So the first thing is we need to get t by itself. So I'm going to move y onto the other side. So if I rewrite, I have p capital T equals 3x. I'm just going to write the minus y plus 1 like this. Now I'm going to divide by p on both sides, and so my final answer is t equals 3x minus y plus 1 all over p. I'm asked to solve for y for b, so I need to get I by itself. So let's multiply by I on both sides. So I get t equals pri. Now I need I by itself, so let's divide by pr, and I get I equals t over pr. All we're doing is solving for the indicated variable. Now we're asked to solve for f, where we have 4d equals t times f minus 3d squared. So let's solve for f. So first thing we're going to want to do is FOIL out this t here. So we get ft tf minus 3d squared t equals negative 4d minus 3d squared t. Okay, now I'm going to divide by a negative t here, by negative t, and I get f equals negative 4d minus 3d squared t all over negative t. Okay, for problem 3, we need to determine if the following relations determine if the function's 1-to-1. So from x to y, we have each x has a distinct y. So since there's only single arrows, yes, this is 1-to-1. For b, since 7 and 4 both map to 22, this is not going to be 1-to-1. Not 1-to-1. Okay. Problem 4 is asking you to use the definition of 1-to-1 to prove that the following are or are not 1-to-1. So, remember the definition is if f of a equals f of b, then a equals b. So, to prove this, we need to say, suppose f of a equals f of b, then this implies three x plus 1, 3a plus 1 equals 3b plus 1. 3a equals 3b by subtracting 1 on both sides. Dividing by 3, divide by 3, a equals b. Therefore, 1 to 1. And we can put our tombstone. Okay, for problem B, we have x squared minus 4, and this is the same thing. So suppose f of a equals f of b. Then we have we have a squared minus 4 equals b squared minus 4. A squared equals b squared. A equals plus or minus b by taking the square root of both sides. Since this does not imply for all a equaling b, for all a, that a equals b, f of f is not 1 to 1. Tombstone it. Okay. Problem part C is going to be the same idea. So suppose, right, f of a, f of b, 3a squared plus 1 equals 3b squared plus 1. 3a squared equals 3b squared. A squared equals b squared. A equals plus or minus b. And we're going to copy the same thing from up here and paste it down here. Let's copy all this. It's going to be the same thing. Copy, paste. So, okay. And we just need to change this. It should be H. D is going to be the same thing. So suppose f of a equals f of b. Then 3a to the third minus 1 equals 3b to the third minus 1. 3a to the third equals 3b to the third. A to the third equals b to the third. A equals b. This one is different because when you do take the cube root, you don't have to do plus or minus. So, thus, meaning f is 1 to 1. Now again, proofs are subjective, so the wording could be different for yours. Okay, for problem 5, we need to find the inverse of the following functions. So remember, the first step is to swap f of x with y, so we get y equals 3x plus 1. Step 2, we get x equals 3y plus 1. Step 3, solve for y, so we get x minus 1 equals 3y by subtracting 1 on both sides. Divide by 3, divide by 3, and we get y equals x minus 1 over 3. Then 4, we get f negative 1 of x minus 1 over 3. Okay, so remember, all of the steps can be found in my lecture about finding inverses. Okay, let's do problem B. So first, y equals 2x plus 1 over x minus 5. 2, we need to swap x equals 2y plus 1, y minus 5, 3. Let's solve. X times 5 equals 2y plus 1, 5x equals. Okay. Let's now move this one and move the 2, so plus 5x plus 5x. So I get x, y equals 2y plus 5x plus 1. So y, x equals x plus 1. Y times x minus 2, factoring that out, we get 5x plus 1. X minus 2, x minus 2. And we are left with y equals 5x plus 1 over x minus 2. So step 4 is to write it as the inverse notation. So 5x plus 1. Okay, so that's going to be our answer here. Okay, and so for C, we do the same thing. So we get y equals 6x plus 1 over 5. 2x equals 6y plus 1 over 5. Remember, these are all the steps of how to find the inverse. So if you are confused, go back and review what the steps are. Now we solve for y. So I get 5x equals 6y plus 1. 5x minus 1 equals 6y. 6y equals 5x minus 1 over 6. So now I get 4 f negative 1 of x equals 6. And that's the answer. Okay, so problem 6 is asking us to graph the following functions. When I transferred it over, it didn't transfer one-to-one, so some of the notation's a little off. But we're asked to graph 3/4 to the x power. So let's have our graph here. Okay, so I am telling you that there's an asymptote, right, for exponentials here along the x-axis. So asymptote of y equaling 0. And if you're unsure about that, make sure to review the lecture videos. But Alex is going to make you graph the asymptote first. Then let's plug in some points. I'm going to start with 0. And I'm going to get 1. And I'm going to do 1, and that's going to give me 3/4. If I do 2, it's going to give me 9 over 16. So I'm just going to plot these. So 0, 1. And then I have 1 3/4, which is going to be down this way. And so I'm just going to use 2 points. And it should look something like this. Okay, so e to the x plus 1. X, y. This is going to be my graph here. My asymptote now is a little bit different because it is going to be shifted up 1 since we have this plus 1. So asymptote y equals 1. So here's my asymptote because I'm shifting up 1. And e to the x is going to, let's plug in 0. So I get that's 2. So 0, 2. And let's say we have 1, so that's e plus 1, which is probably around 3.7-ish, so almost 4. So 1, 4, we'll say it's like right here. So my function should look something like this. Again, you can use approximations when you're doing it by hand, but on Alex, you would just type in like e plus 1 as the answer to plot the point. Okay, so now we need to graph natural log of x plus 2. So we're interested in doing this one. So we know that our asymptote is going to be at y equaling, or now we have vertical asymptotes for these, but since we do have that shift on the inside, we're going to have to keep in mind that it's going to move to the left 2 places. So we should have an asymptote somewhere over here. So x equaling -2 is where the inside equals 0. So let's do our x and y. So let's do 1, or let's do -1 first. So that'll give me ln of -1, that's 1, equals 0. So -1, 0. It's going to be about here. Let's do 0. It's going to be ln of 2. We don't know what that is, so it's just going to be like somewhere over here. So if I have those 2 points, I can just graph something like this. Okay, now I have log 1/4 of x. So again, I want to draw my x and y. My asymptote for this one is going to be at x equaling 0. So now I'm going to plug in some values. I'm going to plug in 1, and that's going to give me 0. Okay, so that's my first point. And now I'm looking to see another point that I can plug in. So I'm going to plug in, let's see, let's do 4. If I plug that in, I'll get log base 1/4 of 4. So 1/4 to the x equals 4, which means that I have 1/4 to the negative 1. So x is going to be negative 1. So 4, negative 1, something like this. So my graph should look something like this as I get closer to 0, right? Because 1/4 will give me 1, plugging in 1/4, so that's going to be like something over here. So it should look like that. Okay, rewrite the following from exponential form to log form. So remember, if we have something like this, we do our little swing around. So that should be log base 2 of 32 equals 5. Log base 6 of 36 equals 2. Log base 1/3 of 3 equals negative 1. Okay, right, we're swinging it around, swing it around. So now I have log base 1/4, 1/16 equals 2. Okay, so that's what we're interested in. Now we're interested in writing them from logs to exponentials. Again, we're going to use our swing around. So we get 5 to the first equals 5. Up, this one doesn't have a base, but remember ln equals log base e. So that's e to the 0 power equals 1. Remember, log without anything there in the base is 10, so that's 10 to the first equals 10. And again, we have 3 to the negative 4 equals 1/81. Okay, now we need to solve and fill in for the missing values. So we are interested in simplifying these. So remember, if we have a subtraction, that's going to be log base 9 of 8 divided by 2, which gives me log base 9 of 4. Adding something to give me the end log base 3 of 55. So it's definitely going to be log base 3. To add, I need to get 55. I need to put 11 here because 11 times 5 is 55. These are using properties of logs. So make sure that you memorize those and understand what's asking. 3 log 10 equals log 10 to the third. So that's all we're going to do is just move that 3 there. Okay, and then the last one we're interested in is searching for this missing coefficient here. So we're going to have negative 2 should be there. So log base 7 of 125 is going to be the same thing. We can write that as 5 to the negative 2, which means negative 2 log base 7, 5. Okay, the next thing that we're asked to do is expand the following statements. Okay, so this first one we have log of 3x squared plus 2x. So the first thing is, it doesn't look obvious, but I'm going to factor in x out in the inside. So I get x times 3x plus 2. Now I can I can write it as log x plus log of 3x plus 2. But once I do that, I cannot expand anything out more. Okay, so I have log of y squared over 2x squared z. So this is going to be log of y squared minus log 2x squared z. So now I have log 2 log y minus the whole thing, or we could just say log 2 minus log x squared minus log z, and then my final step is 2 log y minus log 2 minus 2 log x minus log z. All right, let's work on this one. ln of x to the 9th, y to the 8th, z to the 7th. So ln of, let's split them up by multiplication. So plus ln of y8. Now I bring their powers down, so I get 9 ln of x, 8 ln of y, 7 ln. Okay, So that's going to be the answer for that one. All right, so now we have log of the cube root of x to the 6th z to the 2nd over y to the 7th. So the first thing, we're going to want to break it down so it's log of x6 z squared all over y7 to the 1/3. Then we can bring that power down, so I get 1/3 log of x to the 6th z squared over y7. Now I have to split everything up. So I go 1/3 log of x to the 6th plus 1/3 log z squared minus 1/3 log of y to the 7th. Now I can bring those powers down. I get 6/3 log x plus 2/3 log z minus 7/3 log y. And this 6/3 will turn into just 2. That's going to be the answer for that one. And this is a 7. Okay, the last problem we have is ln of the cube root of x to the 5th, y to the 7th, z all over w squared. So the first thing I'm going to do is break this down by fraction. So ln of the cube root of x5, y7, z minus ln of w squared. That's the first thing I'm going to do, and the reason is because it's not all under the radical. Next thing, let's break down that 1/3 ln of x to the 5th, y7z minus, and I'm going to bring that 2, so 2 ln of w. Then I can split this up. I get 1/3 ln of x to the 5th plus 1/3 ln y7 plus 1/3 ln z minus 2 ln w. Now I get 5/3 ln x plus 7/3 ln y plus 1/3 ln z minus 2 ln w. So that's going to be the answer for that one. So that is the answer for that problem. Okay, so now we're asked to condense the following statements into a single log, or a natural log. So the first thing that we're going to do is put back the powers. So we have 4 times, let's put this to, so log c x squared minus log cz plus log cw to the 1/8. Okay, that's our first step. Next, we want to start condensing everything down. Now, whenever you see this minus, but then there's a plus there, right, you have to be really careful. We could reorder, right? They're trying to trick us. And so we just want to make sure that it's not, we want to make sure that this is right. Okay, so we'll have, let's reorder. So we get 4 log c x squared plus log cw 1/8 minus log cz. Okay, so now I can write 4, I have log of x squared, and I have this base c, w to the 1/8 minus log cz. Then that gives me 4 log x squared, w 1/8 all over z base c. And the last thing is I get log of x squared w 1/8 all over z all to the 4th, and you can distribute that out and you'll get log c base c. W to the 1/8 to the 4th is going to give me square root w, and then x, so we can write x to the 8th w square root w all over z to the 4th. So that's probably what you're going to want to use, this simplified answer. Okay, so now we need to condense back the natural logs, so we'll just start putting powers back. So we get ln of z to the 2nd power plus, this one has parentheses on it, so let's do what's on the inside first. So we get 5 ln y of y minus ln of x squared. Then I'll get ln of z squared plus 5 ln, so that gives me y all over x squared then that gives me ln of z squared plus ln of y to the 5th all over x to the 10th, which then gives me ln of y to the 5th z squared all over x10. And that's going to be my answer. Okay, the next thing we need to solve for x, and if you remember how to solve for x with logs, first thing that we have to do is we are going to, whenever there's logs and they're both the same base on either side, you just take the argument. So that's x plus 1 equals 2x minus 5. Now solve. So we get, I'm going to move x over on this side and plus 5 plus 5. So I get 6 equals x. And so now I can just check it. If I plug it back in, I will indeed get an answer. So x is going to equal 6 for this. Okay. That was the first kind of problem. Now we have natural log of x equals 5. Remember, another way to undo this is to take the exponential of both sides. So e, raise both sides to the e. That'll cancel these out, so I get x equals e to the 5th. Okay, that's another way to do this one. Or you could rewrite it. Okay, we have the same kind of problem where logs are both on either side. They have the same bases. We set them equal to each other and solve. So we have x plus 6x equals 7. So I have x squared plus 6x minus 7 equals 0. So if I factor that, I will get x minus 1 x plus 7 equals 0. So x equals negative 7 and x equals 1. Now I need to test to see if this works into my formula. So if I plug in negative 7 into here, I get 49 minus 42. Okay. And that gives me a real number. Okay, check. And if I plug in 1, I also will get 7. So both answers will work. So these are the solutions. Okay. Okay, let's do this one. We have 2 plus 2 natural log x equals 10. Let's subtract 2 on either side. So we get 2 ln x equals 8. Divide by 2, divide by 2. I get ln x equals 4. Take exponential of both sides, and we get x equals e to the 4th. Okay, same thing with this one. Let's divide by 2. Divide by 2. We get ln of 5x equals negative 5 over 2. Take the exponential of both sides. I get 5x equals e to the negative 5 over 2. Divide by 5, divide by 5. X is going to equal 1/5 e to the negative 5 over 2. That is going to be my answer. And of course, you'd want to check that to make sure that that is the correct answer that you will get back. You can never plug in negatives into the exponent, into your variable here, like into here. But remember, negative exponents indicate small decimals. All right, let's do this one. So we get ln of x plus 2 minus ln of 3 equals 1. Now, whenever you have logs mixed with constants, you have to condense. So the first thing I'm going to do is condense, so I get x plus 2 over 3 equals 1. Now I take the exponential of both sides, so I get x plus 2 over 3 equals e. Multiply by 3, multiply by 3. X plus 2 equals 3e minus 2 minus 2. X equals 3e minus 2. Okay, so that's what we're going to get for that. And of course, we want to just check our answers to make sure that this works. So if I plug it in, I should get 3e minus 2 plus 2. So that gives me ln of 3e minus ln of 3. I can split that up, and I will indeed get 1. Check. So this is my answer. Okay, so the next type of problem we're going to want to solve are some exponentials. So we have 27 to the 2x minus 1 equals 3 to the negative 6x. So first thing, 27 we can write as 3 to the 3rd, and then we still have that 2x minus 1 equals 3 to the negative 6x. And when their bases match, then we set the exponents equal. So that's 3 times 2x minus 1 equals negative 6x. So that's 6x minus 1 equals negative 6x. Add 1, add 1. So I got 6x equals negative 6x plus 1. Add 6x, add 6x. I get 12x equals 1. X equals 1/12. And if I plug it in, I should get the right answer. Okay, next thing, we have 7 to the x plus 1 equals 49 to the 3x. Let's rewrite 49 as 7 squared to the 3x. So we get 7, so we get x plus 1 equals 6x. Minus x minus x. We get 1 equals 5x. X equals 1/5. Okay, next thing we have is 16 to the 3x plus 4 equals 128. Okay, so let's break down the 16 and the 128 into terms of 2 because we're not going to be able to get them into terms of 4. So 128 is 2 to the 7th. So let's write that 2 to the 7th. 16 is 2 to the 4th. So that's 3x plus 4. Now set their exponents equal, so we get 4, 3x plus 4 equals 7. 12x plus 16 equals 7. So we get 12x equals, we have 7 minus 16, that should give us a negative 9. Divide by 12, divide by 12. X equals negative 9 over 12, which also equals negative. That is 3 over 4. Okay. And that's going to be the last problem on our test review. So make sure that whenever you're doing these types of problems, you always check your solutions because sometimes with the logs, especially, you might not get answers that work. Now, for our case, this answer, right, this x equals negative 7 and x equaling 1 did work for us, but it might not always happen as that, especially if you were to get a problem that factored and it didn't give you that. So just make sure that you always check your work.